Before we begin, I was wondering how many of you were familiar with the concept of TEEs, Trusted Execution Environments. Like anyone? Okay, one, two, like a couple of people. Okay. What I would like to discuss today is the evolution of the notion of oracles and what TEEs mean for that. And I'm specifically going to be focused on the cluster of topics around interoperability. So the evolution we've seen basically starts with oracles being used to bring data about the real world on-chain, on a single chain, as Ethereum used to basically reflect all of the blockchain reality in terms of smart contracts up until a few years ago. And so part of that reality, part of the real world, used to be price feeds. And oftentimes would price discovery be happening on Binance or whatnot. And so we would be using those oracles to bring data about prices on chain in order to actually enrich smart contract capabilities. Now, today, we are in this multi-chain world. We have many rollups out there. We have even non-EVM chains that are gaining traction. We have Alt-L1s. And so what I would like to show to you is how to expand the notion of an oracle from this very constrained, basically price feed kind of notion to a more general and maybe blockchain-focused one that is bringing states from other chains into your home chain in the form of a state root. And so what this means under the hood, in technical terms, is the combination of the ability to real-time prove the state of another chain to your chain with the ability to code, to program, to express some sort of logic in a way that other people, other developers can read, but more importantly, in a way that's interpretable by some super component or some other layer that has access to the different chains with which we are interoperating. But why do we even bother about this? Like we have our Binance price feeds, what's wrong with that? Well, what's wrong with that is that today, crypto feels like a set of islands where you can quite nicely and pleasantly walk on each of them and meet your friends and do your business and get coffee, whatnot. But then, in order to actually meet someone who's on another island, on another blockchain, on another L2, you actually need to go the extra mile and look for a bridge and ideally check the trust assumptions behind that bridge and possibly wait for a while and risk that your assets may be wrecked and whatnot. And so interoperability, I would argue, is not just building bridges. It's not just having a way to go between the islands, but it's actually abstracting away those islands in the first place and letting developers treat the different applications and the liquidity pools living on the different blockchains as though they were accessible in this holy grail paradigm of composability. And by composability, I mean the ability to combine those DeFi Lego building blocks together without the individual blocks having been planned or designed to be used by another one. So this is kind of the Unix approach of having small CLI tools, highly specialized to do one job and one job only, but able to be combined with others in a very easy, trivial, standardized way, like for instance via piping. And then my take is with programmability and RTP, real-time proving, we actually get to bring proper interop about, proper composability about. So let us focus on the status quo in Ethereum land. In Ethereum land, we have our L1, which produces blocks every 12 seconds. And then we have ZK rollups, which currently are able to produce ZK proofs and provide data availability to the L1 in a matter of maybe an hour. or if they don't have billions in the treasury, probably even less. And then we have optimistic rollups, where all the value lives, basically, nowadays, which require 7 days for the standard, indeed composable as well, canonical bridges to update the state of such rollup on the L1. Now, with real-time proving, and in our case with TEE-enabled real-time proving, this special layer, being this, we call it T1, it could be any sort of abstraction layer that is able to follow other nodes, other rollups nodes, and prove its own state then to the L1 within less than 12 seconds. This is something that I would call real-time proving for rollups, real-time proving for gas limits that are way above the 36 million L1 gas limits, and block times that are way below the 12-second block time. And so this is something that's really, really challenging with technologies such as ZK proofs, which is the reason why ZK rollups and optimistic rollups are that slow in the first place. And so how we do this, TLDR, we'll get into more detail later if we have time. We basically have T1 follow nodes of other rollup sequences within this reinforced, security-hardened TEE infrastructure, and therefore be able to provide TEE proofs about facts from Arbitrum, about facts from Scroll, to its own users, to consumers of such facts, in a way that's super fast and attributable. And at the same time, it exposes the ability for those consumers to actually request that transactions be put on those other rollups, that a transaction that maybe opens a user position on Euler Arbitrum be opened by the network of TEEs on the user's behalf. And all of that within delays that are negligible, within millisecond delays, thanks to the introduction of TEEs. Now with this, my claim is that T1 introduces interoperability, introduces composable interoperability to this otherwise fragmented, siloed rollup ecosystem. And so who are we? Where is this even coming from? Well, we've both been building in the space for a while. My co-founder previously co-founded Secret Network and grew it to a multi-billion project using TEEs for privacy, learned his lessons there. I previously was working with Scroll, trying to actually use zero-knowledge proofs to scale Ethereum, and learned my lessons there as well. And now we came together to basically try again and try better this time. So why bother? Again, there was this image of islands. What does this mean in practical terms? Well, I would like to give you a quick TLDR on 3 use cases, 3 areas that are of interest to some people. One area where oracles for states of other chains are super practical are so-called intent bridges. And that is not what most people think about when they see intent bridge across whatever. This is not about faster bridging. This is about the ability for solvers who are doing the real work behind the scenes for an intent bridge to get the fact about having filled the user intent on the target chain over to the home chain faster and therefore be more capital efficient. And so in this, we call it ERC 7683 repayment paradigm, we are actually able to lower the repayment latency in this workflow, where usually the settlement verification step number 3, is just a black box, and the solver is supposed to somehow convince the escrow contract. We are actually able to lower the delay from 60 minutes on average to 1 minute on average. And we have this thesis that this be able to lead to way tighter quotes for users, which we recently started trying to falsify by launching a bridge using our cross-chain read capability, and you can actually go and see for yourself, if you go to beta.t1protocol.com, that the quotes that you are getting are significantly more attractive than the quotes you are getting on a standard intent bridge, such as a cross. Now, the other area, the second area, TLDR cross-chain vaults. How cool would it be if you'd be able to abstract away this standard use case where you have some money and you are looking at the different chains, comparing yields on the different instantiations of the same, maybe Euler or Morpho vault, just to decide, do I go to Arbitrum, do I go to base? Well, 3% here, 4% here, so I'm gonna go to the 4% one. And how common is it to find yourself realize a week or a month later that your vault that you had picked has been performing under-optimally, has been overutilized, whatever, and giving you way lower yield for weeks. This happens a lot. And so with the ability to read the different rollups in almost real time and program based on those reads, are you able to actually abstract away this complexity of picking the right vault and present a unified cross-chain vault product to the user who just needs to say, hey, I want any instance of Euler on any of these 5 chains I trust, just check every day and move my funds if necessary. We ran some numbers and found out that this, on average, is able to increase the APY by something like 20%. And finally, the last area, what you can do with the real-time proving and programmability is what I call same block deposit trade withdraw, and this paradigm where there's this specially crafted interoperability layer that we call T1 in this case, that is able to go to the other chains fast. You are able to have this holy grail of user experience where a user residing on his own chain, let's say Ethereum, is able to express the intent of maybe willing to trade his token against another token at some limit price, at some slippage, in a way that T1 interoperability layer is able to pick up from the L1, run the trade using its multi-chain capabilities, and issue a withdrawal from T1 into the L1, all in the same L1 block, all within 12 seconds. So this is something that hasn't been possible before, and this is something that I hope will open up the capacity for normal users to not have to keep thinking about which chain, which RPC, etc. they are interacting with, but actually give them the UX that they need. So how is this even realized under the hood? How is this even secure? Can you trust this? Whenever you hear TEEs, you might remember the sgx.fail exploits, or maybe you are following Twitter and you instantly think about tdx.fail exploits. And this is not for no reason, and so you definitely need to think about defense in depth. This is something we've been thinking about from the earliest days onwards, and we came up with a system where we basically start with TEE proofs for the speed. We render the computation that's running inside TEEs deterministic, even though it's non-trivial to do so. And this enables us to require multiple TEEs, at some point maybe multiple vendors, etc., to reach consensus on the new state of T1. And the beautiful thing about a deterministic system is it is an attributable offense to have lied, to have broken into a TEE and made it vote on something that it shouldn't have. So this lets us slash stakes, and this also lets us require zero knowledge proofs if there's a situation in which the stake would not be enough to cover for the security budget. I'm happy to discuss the details of our design, so hit me up on Twitter, hit me up on Telegram. And I'm also happy to take any questions if we have time, but I'm seeing signs we don't. So thank you so much for listening.